Hey everyone, and welcome back to All Things Space. Now let's get into the video. Lately, scientists have been busy studying exoplanets, and big clues have been found with regards to the solar system from that. Here's what we found in the first exoplanet images. But before we begin, be sure to like this video and subscribe to the channel so you don't miss out on any of our future videos. The half-Jupiter mass ultra-hot planet. Many organizations have been searching for the first planet orbiting a sun-like star since the 1980s. Some candidates appeared and then vanished. Others needed dozens or hundreds of sightings to be confirmed formally. However, an observation made in January 1995 proved to be accurate. Didier Queloz, a graduate student at the University of Geneva, was working on the hunt for extrasolar planets using radial velocity, or wobbles, with his professor Michael Mayer. His discovery was said to be a happy accident. He picked 51 Pegasi, an F-type star around 50 light-years away, from a library of radial velocity signatures. He was attempting to calibrate his planet-finding algorithm, and the star was one of a few viable options. Everything came together that night with a strong signal every 4 days or so. The object's lowest mass was found to be around Jupiter, indicating that it was unmistakably a planet. While astronomers thought that such periods were feasible, they weren't expecting to discover one in such a short time. "I was the only one in the world at that time who realized I had discovered a planet," Queloz told the BBC in 2016. "I was terrified, to tell you the truth." There was cause to be concerned. Identifying a planet was, and still is, difficult, and there were many errors, ghosts, odd data points, and other hitches that never appeared to result in the formation of a planet or a brown dwarf. The half-Jupiter mass, fast-moving, ultra-hot planet existed there, according to Queloz's findings. Planets circling a distant star. Queloz spent the remainder of 1995 trying to persuade Mayer that he had identified a signal, not an instrument fault or any other observational quirk. In October 1995, their study was ultimately published. Following up on the observations, astronomer Geoff Marcy, who was later fired from the University of California, Berkeley after sexual harassment allegations, discovered that the Geneva team was correct. He and collaborator Paul Butler were able to find the same signature at a different observatory. Using telescopes on Mauna Kea, a volcanic peak on the island of Hawaii, astronomers have captured the first images of planets circling a distant star. 3 massive planets have formed, orbiting HR 8799, a star in the Pegasus constellation 130 light-years from Earth. Images of exoplanets outside of our solar system have only been captured from space or inferred indirectly until now. Signs of life on rocky planets. "We've been attempting to scan planets for 8 years with no success," said Bruce McIntosh, an astronomer at Loris Livermore National Laboratory in California. "The planets are many times Jupiter's mass." According to research published in the Journal of Science, the scientists employed the Keck and Gemini telescopes on the island. In the same issue, Hubble Space Telescope images of another planet, Fomalhaut b, 25 light-years from Earth, in the constellation Piscis Australis, are published. It is the first exoplanet detected solely via visual means. "I almost died when I verified that Fomalhaut b circles its parent star at the end of May," stated astronomer Paul Collis at the University of California, Berkeley. "Seeing a planet you've never seen before is a deep and overpowering experience." Although none of the planets are expected to harbor life, scientists think that at least some of the solar systems have smaller, rocky exoplanets, similar to those of the likes of Mars or Earth, that are far more difficult to find. "We think that everyone has the right to knowledge based on science and truth, as well as analysis based on authority and honesty. That's why we took a different approach. We decided to make our reporting accessible to all readers, regardless of where they reside or how much money they have. More people will be better educated, unified, and motivated to take real action as a result of this." How was it that the very first extrasolar planets were found? The first exoplanet, or planet beyond our solar system, was identified in 1992 by scientists. However, it was not in the shape that they had expected. Outside of black holes, neutron stars are the densest objects in the universe. They originate when a massive star dies and the collapse of its core causes it to blast outward. Simply said, the star grows too huge to continue and expels all of its energy into space. The core serves as a type of detonation starting point. When that core collapses, the star becomes a neutron star or a black hole, depending on its size. Pulsars are neutron stars that emit regular pulses in radio frequencies. Consider many of them as drummers, with quick, consistent rhythms. Millisecond pulsars, for example, drum so quickly that they would put napalm death drummer Danny Herrera to shame. Those pulses are so regular that astronomers can tell if anything is wrong if they don't occur at the appropriate interval. Pulsar planets are a cross between a chimera and a zombie. When a star bursts, the planets in its systems are typically killed or thrown away by the shockwave. However, after the violence has subsided, the gas and dust might condense again. This implies that the 3 planets in B1257 might be made up of remnants of planets that came before them. Given the tremendous radiation in these systems, nearly no one has ever considered the B1257 system as a potential home for life. While the finding of planets orbiting another star in 1992 was significant, it left scientists with no confirmation of planets around a main sequence star like the Sun. That type of validation would have to wait a few years. Why star-by-star studies helped the discovery of exoplanets? Exoplanet detections in the early days were defined by an emphasis on star-by-star investigations, nearly invariably by radial velocity, making radial velocity one of the most effective techniques for identifying exoplanets, with 746 worlds discovered as of March 2018. Compare that to 90 planets discovered by direct imaging, which is confined to huge, hot, and young planets, and 67 planets discovered through microlensing, which occurs when a large object passes in front of a background star and serves as a gigantic magnifying glass. These are the third and fourth most successful ways of an exoplanet discovery. However, the transit technique of identifying exoplanets has been by far the most effective. It was discovered 2,789 times in the same time period as the radial velocity head count. Because there are 3,705 planets in the universe, transiting planets account for 75% of all planets identified. However, one spacecraft, Kepler, discovered 2,648 of the 2,789 planets, including the first ever multi-planet system. The exoplanet of Barnard's star. We barely have 1,000 planets to deal with if the worlds identified by NASA's Kepler spacecraft are excluded. That's because Kepler was designed to sweep a tiny piece of sky and count as many planet transits as possible. Previous polls only include a few dozen stars at a time, if that. If nothing else, Kepler demonstrated that planets aren't uncommon and that there are millions, if not billions, out there waiting to be discovered. For example, researchers operating under a strong cloak of secrecy claimed in 2016 that they had discovered the nearest planetary system to Earth, orbiting around the star Proxima Centauri. That team, formerly known as Pale Red Dot, subsequently changed its name to Red Dots. Their research has expanded to include other neighboring systems, including Barnard's star, where they discovered promising evidence of an exoplanet in November 2018. This is partially because, thanks to so much of the hard labor done on star censuses, we are on the verge of learning previously unimaginable data about planets, and we may be studying them one by one with massive telescopes and improved optics. That brings us to the end of the video. Don't forget to subscribe to our channel and hit the bell so you don't miss out on future videos. If you enjoyed the content, then do leave a like. So until next time, take care and goodbye.